Welcome everyone. In this course, I will cover what is NumPy, why do we use NumPy, NumPy arrays and matrices, indexing and selection of NumPy arrays, and some mathematical and statistical operations using NumPy. I put the time details of these three sections in the description box so you can directly go whatever section you like. What is NumPy? It is an open source numerical library. It stands for numeric Python. There are two types of NumPy arrays, one-dimensional arrays, that means vectors, and two-dimensional arrays or matrices. Why do we use NumPy? It is used for multidimensional array and matrix data structures. It is very commonly used in data science and machine learning. It is so important for data science with Python because almost all Python libraries for data science rely on NumPy as one of their main building blocks. NumPy arrays use less memory than normal Python list. NumPy is faster than normal Python to read the information. It has a lot of convenient broadcasting operations. In this course, I will use Jupyter Notebook from Anaconda. You can use whatever environment you like, but if you are completely new user, please go ahead and check my previous video where I showed how to install Anaconda and Jupyter Notebook in your system. The link is given in the description of this video. Now let's get started. Here I am at my Jupyter Notebook. Let's create a Python list first. Python list. To make this comment, go up here, select markdown, shift enter. Let's create the first object L1 equal to 1, 2, 3. We can print this object for Python list. Let's create another object L2. Let's say 3, 6, 9. You can also print this. Now if you wanna multiply these two objects element wise, you'll see Python list cannot handle this kind of multiplication. Now we create a NumPy array from this Python list. So let's import NumPy as NP by convention. So let's convert L1 Python list into NumPy array. So L1 equal to NP dot array. We pass this L1 list into this array. Now print this. So you see now it becomes a NumPy array. Same thing goes for L2. NP dot array, pass the list, then you're gonna get the second array L2 as a NumPy array. Now let's multiply these two arrays element wise. Now you see NumPy can easily handle this kind of element wise multiplication. So you see the first element times the first element, 1 times 3 which is 3, 2 times 6 which is 12, and so on. Now let's create a two-dimensional array. Before that, let's create a 2D list, NumPy list 2D equal to, it's a list of list, that means nested list. So I'm gonna use double square bracket 1, 2, 3, and another list, let's say 2, 4, 6, and the third list is say 1, 6, 9. And if we print this list 2D, so it's a simple NumPy Python list. Now we convert this into two-dimensional array. My 2D array equal to NP dot, we pass this two-dimensional array list 2D, and if we print this, shift enter, so we get a two-dimensional array or 3 by 3 matrix. Now how do we find the dimension and shape of this array? There is a method called ndim to find the dimension. Let's say L1 dot ndim shift enter, you're gonna get L1 is a one-dimensional array. If you look up here, so L1 is a one-dimensional array. And also for my 2D dot and dime, shift enter, so I see this one is two-dimensional array. Now how do we get the size or shape of this array? There is a method called shape. So L1 dot shape, so you're gonna get 3 comma, it means it's a one-dimensional array, it has 3 elements. And for my two-dimensional array dot shape, so it's a 3 by 3 matrix. If you see here up here, it's a 3 by 3 matrix. Now we can also copy NumPy array, but you need to be careful whenever you copy an array. What I mean by that, let's see, suppose a equal to np dot array and pass a list, say 1 comma 3 comma 6, and let's say b equal to a. Now if you print b, so b equal to a. Now if you change the first element of b of 0, you know the NumPy array, the index of NumPy array starts from 0. So it's a 0 index, then 1, then 3. So b of 0 equal to, let's say, 0. Now if you print a, you see a also changed. Whenever you change b, a will also be changed. So to keep a unchanged, what you're gonna do, you use a method called b equal to a dot copy. So whenever you copy something, you use this method b equal to a dot copy to keep a unchanged. We can also grab the data type of the object in the array. So there is a method called dtype. Suppose L1 dot dtype. So you see it's an integer with 32-bit. And if you have, let's say, another array of 3 equal to np dot array, pass a list, let's say 0.1, 0.3, and L3, if you print this, oops, I made this parenthesis. Okay, so L3 is a floating point. Now if you check this data type for L3 d type, then you see it's a floating point. There are lots of building functions to generate arrays. Now let's explore them. The first one is arrange. np dot arrange, put 0 to 10. If you shift tab here, you see the argument, the starting point, ending point, then step size. The by default step size is 1. If you don't put anything, then it's 1. So let's run this code. So you got the step size is 1, it's increasing by 1. And notice here 0 is included and the ending point is excluded. Now if we specify the step size, let's say 2, then it will be increased by 2. If you want to put the step size is 3, then it will be increased by 3. Then there is another function to generate the arrays of zeros and 1. One is called np.0. You can also generate the arrays of zeros and 1 using the following function, np.zeros, let's say 5. So you're gonna get an array of 5 zeros, or you can get a matrix or 2 by 2 array, two-dimensional array, zeros. Then you pass an ordered pair, let's say 3 by 3. Then you get a 3 by 3 matrix of zeros. And for ones, np dot ones, you just pass the number, how many elements of this array you want. Same thing goes for two-dimensional arrays of 1. So np dot ones, you're gonna pass a ordered pair, let's say 2 by 3. Then you're gonna get 2 by 3 matrix of ones. If you want to get all, or let's say 4, then you simply multiply by 4. So you're gonna get a matrix of 4. There is a method called linspace. It returns evenly a space number over a specified interval. So let's look at that. np dot linspace then pass the number, let's say 0 to 10, comma 3, shift enter. So look at here is a and starting point is 0, ending point is 10, and you wanna get 3 evenly spaced number, so you're gonna put 3 here. If you want 20 equally spaced number in this interval, you're gonna put 20. Then if you enter here, you're gonna get 20 number. If you wanna get only 5 numbers, then you're gonna get 5 equally spaced number. We can also create identity matrix using the NumPy array np.I. If you wanna get a 3 by 3 identity matrix, just put 3 there. So it's a 3 by 3 identity matrix. Or if you wanna get 5 by 5, just simply replace 3 by 5. So it's a 5 by 5 identity matrix. We can also use NumPy as a random number generator. So now let's use the first function rand, np.random.rand. If you put 3 there, then you're gonna get 3 random numbers. It's uniformly distributed, lies between 0 to 1. Now if you want 5 numbers uniformly distributed, lies between 1, you just simply replace 5 3 by 5. Now if you want to get a two-dimensional array, np.rand, you simply now if you want to get if you want to get the two-dimensional random array, you're gonna put np.random.rand. Just put, let's say, 5 by 3. Then you're gonna get a 5 by 3 matrix. All the entries lies between 0 to 1 and uniformly distributed. And the another function is called randn, which is normally distributed. np.random.randn. If you put 5 there, then you're gonna get 5 numbers. These are normally distributed. That means the mean is 0 and the variance is 1. And also, if you want to get a two-dimensional array which are normally distributed, simply you put the dimension randn as before, let's say 4 by 3. Then you're gonna get a 4 by 3 matrix. All the values are normally distributed. Now if you wanna find a distribution of integers, now if you wanna create a random numbers, random integers between an interval, you're gonna use rand int. So np.random.rand int, and just pass the number there, let's say 0 to 10, and shift enter. Then you're gonna get a random number which lies between 0 to 10. Remember here 0 is included, but 10 is exclusive. So if you want more numbers, let's say 3 random integers between this interval, you're gonna put there the third argument. So you're gonna get 3 random integer. If you wanna get more, let's say 7, then you're gonna get 7 random integer. Even if you wanna get 15 random integer, you're gonna get 15. In this case, you get some repeated, as you can go only 0 to 9. And also you can find a matrix np.random.rand int, and simply you put the dimension, let's say 1 to 50, and the size of the matrix is, let's say, 3, 4. Shift enter. Then you're gonna get a matrix of size 3 by 4. All the numbers, integers, lies between 1 to 50. Now let's talk about seed. If you wanna generate same random number every time, you're gonna put a seed. So np.random.seed. Let's say the seed is 10, it's arbitrary number. Then np.random, let's say 5. So if you shift enter, you're gonna get 0.77, 0.02. If you run this cell again, you get the, every time you run, you get the same result. But if you change the seed, let's say 15, then the result will be changed. But it would be the same for the same seed. Now if you change this, but if you run only this piece of code in a separate cell, you're gonna get different result for every run. Okay, now let's talk about some attributes of NumPy. Suppose L1 equal to a NumPy array np dot arrange 36. So if you print this, it's an array of 36 numbers. We can reshape this array into two-dimensional array. So L1 dot, there is a method called reshape, shape, reshape 6 comma 6. If you run this, you're gonna get a 6 by 6 matrix. If you change this number, let's say 6 over by 5, it doesn't make sense because you have 36 elements here, it doesn't match. So it's a 6 by 6. You can reshape it back like 36 by 1 or 1 by 36. There are some useful methods to find the minimum and maximum value of an array and location of that max and min. Let's explore that. Suppose L1 equal to np dot random dot ran int lies between, let's say, 0 to 50. We have 10 numbers there, and L1. So let's find the max of this array. The method is called max. So if you run this, you're gonna get 46, the maximum of this array. And if you wanna find the minimum, min, then you're gonna get the minimum. Now we can also locate this max. You see the maximum, it lies at the index number 0, but there is a method called argmax, L1 dot argmax, then you're gonna get the 0. That means at the location of 0, the maximum, you're gonna get the maximum of this array. And same thing goes for minimum, argmin, shift enter, then you're gonna get the minimum at the position 3. So remember, the index start from 0, so 0 1 2 3, so which is 2, we got the 2. One last thing I want to mention before finishing this section. If you press Control Enter, you just run the cell. If you press Shift Enter, you run the cell and move to the next cell. If you press Alt Enter, you run the cell and create a new cell next to it. Thanks, see you next section. In this section, I'll be talking about indexing and selection. Let's import NumPy as np by convention and create a NumPy array np dot arrange, let's say 1 to 20, increase by 2. So this is the NumPy array. Now to grab a single value, I simply pass index number. What I mean by that, if I want to grab this, the very first value 1, so L, the index number for the very first value is 0. As I mentioned earlier, the index for array starts from 0. So shift enter, so you can easily grab this value. So now if you want to grab the next value 3, you simply pass the second index number, which is 1. So we can grab easily the second value 3. Now if you want to grab the very last entry, which is 19, you don't need to count, you simply pass -1, then shift enter, you can easily get very last value 19. Now how do you get values in a range? Suppose you wanna get the value from index 0 to 3, the first 3 values. So what you're gonna do, you simply pass 0 to 0 colon 3, 0 colon 3, shift enter. So you simply grab these 3 values. You can also simply put colon 3, you don't need to put 3, it's essentially the same thing. Now if you want to grab the values from index number 3 to all the way n, you simply pass 3 colon and shift enter, you get from index 3 to all the way end. Another interesting thing of NumPy is broadcasting. Normal Python list does not have ability to broadcast. With the NumPy arrays, you can broadcast a single value across a larger set of values. Let's look at an example to understand the broadcasting. Suppose there is an array L1 equal to np dot arrange, let's say 1 to 25, increasing by 3, and let's print this. Now let me grab a slice L1 0 to 3 and assign a value 20 and print this. Now you see this 20 broadcasting to first three elements. That means the first three elements replaced by 20. One important thing you need to know is whenever you make changes in a slice, the original array will also be changed. So to keep the original array unchanged, you need to use the copy method. If you don't use the copy method and if you make any changes in the slice, your original array will also be changed accordingly. What I mean by that, let me grab let me create another array L1 equal to np dot arrange, let's say 1 to 20 and print this. Now let me grab a slice of L2, which is equal to, let's say, L2 and 0 to 3, and if you print this slice L2, so it's the first three elements. Now if you broadcast slice L2 and you select all the values, just put the colon, which is equal to, let's say, 20, and if you print this slice L2, then you easily broadcast these 20 numbers over this slice. How about the original array L2? If you print this, look at here, the first three values also changed with this slice. So to keep L2 unchanged, what you're gonna do, you simply use the copy method. We also mentioned this earlier. So in this line, you're gonna put, let me run this cell again, then put dot copy method, dot copy, and shift enter, shift enter, shift enter. Now if you look at 20, so L2 becomes unchanged. Now let me create a two-dimensional array. My 2D equal to np dot array and pass a list. It's a list of lists, so double square bracket 1 2 3, and the second list, let's say 3 6 9, and the very last list is, let's say, 1 5 7, and let me print this. So if we look at the shape, dot shape, we talked about that earlier. So it's a 3 by 3 matrix. So from this matrix, if you want to grab the very first value 1, so which is row number 1 and column number 1, but the index starts from 0, so the index for the row is 1 and the index for the column is 1. So you just simply pass my array. In the first square bracket you pass 0, which is the index number for row, and in the second square bracket you also pass 0 for the index number of column. Shift enter. So you can easily grab the first value. We can also put only one square bracket 0 comma 0, or you can simply put 0 and press enter. You grab the first entry. Now if I wanna grab the first row, the entire row, now if you wanna grab the first row, the entire row, what are you gonna do? You simply pass 0, shift enter, or if you wanna pass the very last row, you simply pass -1. you don't need to specify the column number. That means it's grabbing all three columns. So shift enter, you grab the last row. Now if you wanna grab the last column, what are you gonna do? You simply put colon, comma, that means you are grabbing all the rows and the last column. Shift enter. So 3, you see 3, 6, 9. So we grab the last column 3, 6, 9. If you wanna grab this portion 1, 2, 3, 6, only this portion, this 2 by 2 matrix. So to grab this portion, you specify first the row you want and the column. What I mean by that, my 2d colon you want. So 1, 2, 3, 6 means first two row means the index start from 0 to 3. 3 is not included, sorry, 0 to 2, 2 is not included, so 0 and 1, comma, and also for column it's 0 to 2. That means the index number for column is 0 and 1. Shift enter, so we can easily grab this first 4 values 2 by 2 matrix. Now let's look at a conditional array. It is a fundamental concept and extensively used in pandas. So make sure you understand this. It's very simple and easy. Let me take an array L3 equal to np dot arrange 0 to 20. The step size is 3. And let me print this L3. Now, if you want to grab some values which are greater than 6, what are you going to do? You simply pass a conditional index. What I mean by that, L3 in the square bracket, you pass L3 which are greater than 6. Now shift enter, you see we grab all the values what are greater than 6. If I run this index, conditional index alone, what I see here, the first 3 values false and rest of them true, because the 0, 3, 6, these are not greater than 6. And this array is called a Boolean array. In this section, I'll cover about NumPy operations, especially mathematical and statistical operations. This operation can also be done in pandas. So let's create a NumPy array L1 equal to np dot arrange 0 to, let's say, 5, and print this. So if we add a scalar number with this array, so what NumPy does, NumPy add this 5 element wise with all the elements. So 0 plus 5 which is 5, 1 plus 5 which is 6, and so on. We can do almost all the operations here, like the subtraction L1 minus 5 we get, so NumPy subtracting 5 from all the elements. Now if you multiply 5, NumPy does the element wise multiplication, and same thing goes for division L1 divided by 5. So 0 divided by 5 which is 0, 1 divided by 5.2, and so on. Now let's create another NumPy array L2 equal to np dot arrange, let's say 0 to 10, and the step size is 2, and L2. And since the dimension or size of these two arrays are same, what I mean by that, the shape L1 dot shape which is 5 by 1, and also L2 dot shape, L2 dot shape is also 5 by 1. So we can do this arithmetic operation for these two arrays. So L1 plus L2, this means it's element wise addition. We can also multiply these two arrays element wise. So we get the first element times first element which is 0, second element times second element which is 2, and so on. We can also divide L1 by L2, then we get a warning but not an error, because we have 0 for this element, or something divided by 0 which is undefined, that's why NumPy gives a result which is not a number n. If you divide by 0, shift enter, it gives an error. And also if we divide some number, let's say 5 divided by NumPy array and shift enter, you see some number divided by 0 which is infinity. NumPy just gives an warning, not an error, and it gives result for rest of the values. But if we do the same thing for Python, 5 divided by 0, it gives an error. Now let's look at some universal functions for mathematics. We can find the element-wise square root and also the sine, cosine, trig function. So what I mean by that, we can find the square root for each value of an array. So np dot square root square root and pass the array, shift enter. So what I mean by that, we are getting the element wise square root here. Square root of 4 is 2 and so on. And we can also find the trig values of for each of the values of an array, NumPy array. So np dot cosine, let's say cosine of L1, shift enter. So cosine 0 is 1 and cosine 1 is 0.5 and so on. We can also find the exponent of L1, shift enter. So we can use the exponent using the NumPy and so on. From the NumPy array, we can also find the summary statistics. What I mean by that, we can find the summation, we can find the mean, variance, standard deviation, maximum, minimum. So let's find the max and mean. And L1 dot max method, shift enter, we get the max, and also we can find the mean using the mean method. We can find the sum method. That means what? We are adding all the values, all these 5 values. If we add these values, we get 10. And also we can find the variance method, and we can find also standard deviation, L1 dot STD, standard deviation. Now let's look at these operations in two-dimensional NumPy array. We have my 2D array. So my 2D dot sum. What I mean by that, it is summing over all the numbers in this 3 by 3, in this 4 by 4 matrix. So if we shift enter here, press shift enter, it's saying x is equal to none. That means we didn't choose any axis, so it's adding all the numbers. If we specify the axis equal to, let's say, 0, that means perform the operation across the row. Shift enter. So 24 is the summation of this first row, and 28 is the summation of the second row, and so on. And we can do same thing for mean along row, x is equal to 0. That means 6 is the mean for the first column, 7 is the mean for the second column, and so on. We can also find the standard deviation variance using this method along x-axis or along y-axis. Along y-axis means along the column. That's all for this course. I hope you enjoyed the course. I'll see you in the next lecture.